These results are obtained with my college. We consider multi-core computer system and concurrent pool in the shared memory of this system. Concurrent pool is some data structure which supports insertion and removing operations. It's not linearizable data structure, and so the order of operations is not it's not FIFO or LIFO. We just do some insert and removing operations. And we have to maximize throughput for this pool. There are some approaches for implementation of concurrent pool, including concurrent queue-based, log-free lists, elimination back-off, combined trees, and so on. Many of them have some drawbacks. In this work, we considered diffraction tree approach. Diffraction tree is a binary tree of high h, each node of which contains bits, determining the direction of path of threads doing some operations with the pool. When thread arrives to the tree, it passes through the tree, and if bit equals 0, it goes into upper subtree. If bit equals 1, it goes to down subtree. And so we distribute load of the leaves of the tree. The most well-known implementation of pool-based diffracting tree is used in compound with elimination array in each of the nodes. So we try to eliminate operations, and then we pass through bits. Each of the leaf correspond to concurrent queue, so we distribute operations between the queue. We propose some different implementation. In this version, we replaced bits by some atomic array of bits, and first time threads by hash function choose bit in this array, and then it pass through the tree and do operations with the queue. So also the other difference is the affinity of the binding of queue to processor cores. So each queue on the leaf corresponds to some processor core. Doing inserting and removing operation, threads choose the queue and do the operations. Here is the structure of our implementation. It contains a diffracting tree, array of bits, concurrent queues, affinity manager, and counters for counting of threads. Here is the algorithm for push operation for insertion of elements. First we increase the counters, then we set the affinity to the core, which corresponds to some queue, and we choose queue and pass through the tree and do the operations. Algorithm for pop operation is similar. And we also propose some other version which use thread local storage for store bits. It's the only difference compared with previous one. And we also propose the algorithm to prevent imbalance of concurrent queues in the leaves, because in some cases more threads address to some queues, so these queues become to be bottlenecks. This approach is based on binary representation of the tree number, and we set some initial values for nodes, and then execute threads. We done experiments on the computer system. We also used synthetic benchmark with some number of threads, and as efficiency indicator we also used throughput. Here you can see the results for proposed pool. We compared the queues in the leaves of the tree. Here is log-free concurrent queue from Boost library, log-based queue based on pthread mutex, and standalone single log-free queue used as the pool. And we can see that using log-free concurrent queue, we can maximize throughput compared with log-based pool. And the result for other version of pool, the result is the same. So this is some variant for pool based on diffraction tree. And as a recommendation, we can say we recommend to use log-free concurrent queues, and imbalance of load of queues wasn't obtained during the experiments. So pool do operation with high performance. Thank you for attention. Yes. Yes, we have done yet experiments with original version of diffraction tree, but we of course do it in near future. Yes, it's a relaxed data structure. We don't care about ordering of operations. We just want to maximize throughput for operations doing by threads. If you mean proof, we didn't some proof of the correctness. It's the data structure which implements insertion and removing operations. And operations thread may do operation in node FIFO and LIFO order. We just no, it's not stack or queue. We just try to determine if object contained in the pool or don't or not in the pool, and we some operations. If number of producer threads more than consumer threads, and so there is no difference between producer and consumer threads, because we just if it's a producer thread, we invert we goes up if bit equals 1 and goes down if bit equals 0. If it's a consumer, we goes up if it equals 0, and vice versa. It's some heuristic for the practice. If I push simultaneously many objects, yes, it's log-free approach, and here we use atomic operations, and so because of using of array, we distribute threads between cells of this array uniformly, and so threads goes through the tree, and then in the following nodes they are distributed, and so on. So they're not supposed to be bottlenecks. there are not supposed to be a queue in the head of in the root of the tree, because they just do operations and go to the next node and do operations and so on. Yes. Yes, because of the structure of diffracting tree, for example, if this bit equals 0, the first thread goes up, and next thread goes down. Yes, if thread which just pop operation, if it meets some empty queue, it just go to the next queue. This approach is used in many of works. But yeah. It may be to propose some balancing method for solving your problem you described, but for constantly active threads which runs operations in some higher rate, the practice shows that queues are load uniformly. So we can, of course, to improve this implementation by some balancing method.